Hello smart mathematicians, let's do question 3.1. It is given that the general term of a quadratic number pattern is Tn is equal to n squared plus bn plus 9, and the first term of the first differences is 7. Show that b is equal to 4. Right, let me explain this one this way. Remember, for a quadratic number pattern, Tn is equal to an squared plus bn plus c. Right, we have T1, which is a1 squared plus b1 plus c, which simplifies to a plus b plus c. And then T2, we have a2 squared plus b times 2 plus c, which simplifies to 4a plus 2b plus c. T3, which is going to be a times 3 squared plus b times 3 plus c, 9a plus 3b plus c. Now, if we have our T1, T2, and T3, T1 is a plus b plus c, T2 is 4a plus 2b plus c, then T3 is 9a plus 3b plus c. Right, and then if we subtract here, we say term 2 minus term 1. Right, let's check the like terms. 4a minus a, that is 3a. 2b minus b, that is b. C minus c is 0. And then here, 9a minus 4a, that is 5a. 3b minus 2b, that is b. Then c minus c is 0. And then 5a minus 3a, that is 2a. Then b minus b is 0. That's why when we're finding a, we equate the second difference to 2a. And then to find our b, we can use the a we get here and 3a plus b. 3a plus b is the first term of the first differences. 3a plus b is the first term of the first differences. And then a plus b plus c is the first term for a quadratic number pattern. So now, they say this is equal to 7. So we need to show that b is equal to what? Is equal to 4. So it is the first term of the first differences. We have 3a plus b is equal to 7. And then we have our a value, isn't it? From the equation itself, we know the coefficient of n squared is 1 here. So we know what a is. A is 1. A is equal to 1. So a is equal to 1. So we say 3 times 1 plus b is equal to 7. And then b is equal to 7 minus 3. B is equal to 4.